Hello, my dear students and the rest of the learners. Welcome to part 7 of that 7-part series of tutorials in computer structured programming in C and Pascal. This is section 1 of 5 in the topic program structure. My name is MemJM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the meaning of program structure, as well as the format of structured programming languages. That is, the format of program in C and the format of a program in Pascal. Let's commence by looking at the meaning of program structure. A program structure is the overall form of a program with particular emphasis on the individual components of the program and the interrelationships between these components. Programs are frequently referred to as either well-structured or poorly structured. With a well-structured program, the division into components follows some recognized principles, such as information hiding, and the interfaces between components are explicit and simple. By contrast, with a poorly structured program, the division into components is largely arbitrary or even non-existent, and interfaces are implicit and complex. At a final level, a well-structured program employs appropriate data structures and the program units with a single entry point and a single exit point, where a poorly structured program has arbitrary data structures and flow of control. Let's now look at the format of structured programming languages. A program format is the accepted arrangement of the various components within the editor while abiding to the rules governing a programming language, thus forming a valid source code that can be executed to solve the problem at hand. Different programming languages have different formats. Remember, in my previous presentations, including part 6 in this series, I defined syntax, and I said that those are a set of rules that govern how instructions are written in a programming language, for example, in C or in Pascal. And therefore, Pascal has a different format from C, as you are going to see in this presentation. We commence by looking at the format or structure for C programming language. Whenever you are writing any program in C, you should pay attention to the following. C is case-sensitive language, and therefore, all the code should be written in lowercase or in small letters. The following is therefore the general format for C programming language. Therefore, whenever you are writing any program in C, it should adhere to the following format. Number one, this is how you put the comments. You use / followed by an asterisk. You write your comment there, and then you have an asterisk and a /. Next, we have this header, #include stdio.h. I will explain what each means just now. #include stdio.h, and you ensure you write it exactly as you can see. Then we have int main. You can enclose void in between, or it can be empty. There can be nothing inside there. In my subsequent presentations, including this tutorial, I will explain what that means. But you have int main. Then we have this symbol. Then we have your set of statements or instructions to be executed, of course, based on the algorithm that you have. Then we have return 0, and we have that symbol, a special type of bracket, the brace, that we call brace. You need to pay attention, my dear students, this format or this structure, because every C program or any code written in C will adhere to most of what you can see on your presentation here on your screen. Let me move ahead and explain what each means. So I have said that this is how we write comments. This is a method of adding comments within your source code. So anytime you have source code and you want to give a comment or write something for documentation purposes or to make your program readable, then you need to integrate comments at various sections. So for you to place any comment, you have to use it or to place it in between these two symbols that you can see. You have to include the /, asterisk. You write your comment, asterisk, /. They are not executed by the compiler. Anything enclosed in between these two symbols here, those ones are not processed or executed by the compiler. And therefore, they are simply for the readers to see and know what each part is supposed to do, including any future programmers that may interact with your source code or with your program. Next is #include stdio.h. What does it mean? What does it stand for? This is a compiler directive to the C processor telling it to include the contents of the standard input-output header file, stdio.h, in the program. Simply, anytime your program is going to make use of input or output functions, as we are going to see, you have to include this statement. You have to include stdio.h. It stands for standard input output, and it is a header file. But for now, just note that we include #include stdio.h, and that is the format that it should adhere to. You must have that sign, you must make use of this sign, and you must make use of this sign. And therefore, this is a compiler directive. It tells the processor or the compiler where to pick certain functions from that you are going to use for input or for output functions within your program. This preprocessor directive must be included in each program, just as I have said, that makes use of input or output library functions. You are going to see these functions in my presentation. Lines beginning with # are processed by the preprocessor before the program is compiled. In other words, the compiler goes to the memory and seeks for the content or the files that have been indicated with beginning with the sign #. So they are first searched for and they are brought into memory, ready for use by the programmer or ready for use by the program at the various parts of the algorithm. Then we have int main, int main. What does it stand for? What does int main stand for? The line or this line shows the start of the main part of the main function of the program, also called the body of the program. And every program begins to execute at this part. So my dear students and the rest of the learners, kindly note, if you have to have your instructions being executed, if you wanted to have your program solve the intended problem, then your set of statements or instructions should be within int main. In other words, they must be written in between the beginning of int main and the ending. In other words, what is in between or what follows int main forms the main part of the program or the body. And therefore, every program should have it, every source code should have it to indicate to the processor where to begin executing the instructions. The parentheses after main indicate that main is a program building block called a function. And therefore, my dear students and the rest of the learners, main is a function. It is the one which controls the rest of the program's execution. In other words, it is the one which determines the flow. Whatever is written in int main is what determines the flow of the processing operations. And therefore, these two brackets, which we call parentheses, this parenthesis and this one, two of them, when they are placed in pair, whatever that is following it is a name of a function or a subroutine. And I will explain the same in my subsequent presentations. Therefore, the parentheses after main indicate that main is a program building block called a function. The optional keyword int to the left of main indicates that main returns an integer or a whole number value. How do I explain about return or what functions return in my subsequent presentations? However, this optional one, it is optional because you can leave it out. So it's not a must that you must have int if the program or the main function is not supposed to return anything. So it is optional. So you can even avoid it, but there's no wrong, there's no evil with having it. But if you have to have int following main, then you must have a return statement at the end of the program, or return 0, which I'm going to explain or expound about just now. If it is not, if your program, if your main function is not having int, then your return must not have return 0. It can just be return. I'm going to explain on the same just now. So if the main function is not preceded by int, it will still be there by default. In other words, even if you don't include int main, it will still be assumed to be there by the compiler. But it is always good manners in C programming to have it, to include it. Therefore, if you don't want the main to return any value, you can replace it with the keyword void. In other words, you can use the word void instead of int. The optional keyword void and closed in the parentheses indicates that the main function does not receive any information. In other words, my dear students and the rest of the learners, what we are saying is that this word here, void, that is put in between these parentheses simply means that this function called main is not receiving any value from anywhere. For now, my dear students and the rest of the learners, don't worry about what functions return. I will expound and explain about what functions are, how they send and receive parameters in my subsequent presentations. For now, just internalize that whenever you are writing even a single program, it should have the function main and a pair of parentheses. In between, this word void can be left out. It does not need to be there. But there's nothing wrong with having it if your main function is not receiving any value from anywhere. It's just controlling your flow of execution of instructions within your main or within the body of the program. So the optional keyword void enclosed in the parentheses indicates that the main function does not receive any information. Then we have the left brace. My dear students and the rest of the learners, kindly note, we call this one embrace. It's not just a bracket. It's not a bracket. It's embrace. We have seen a parenthesis. Now, this is called embrace. So after the main, after you have the function main, just as you have seen, once you have the function main, you can see from the structure that after the function main, this one, what follows is this brace. This is the brace I'm explaining about. This brace, what is the function or what is the purpose of the brace? Ordinarily, whenever you have any function, it has some things that it's supposed to do, and those things are enclosed in between this opening brace and this closing brace. That's important. So even the main has the two braces. Let's move on so that I can explain to you what then those braces stand for. And therefore, the left brace, which I'm calling the opening brace, the left brace indicates the beginning of the body of every function, and a corresponding right brace indicates the end of the function's body. In other words, even in main, whenever you have any function like main, you must have the left brace indicating the body or the starting point of the body of that function. And at the end of the day, after you have been able to do everything in between the left brace and you are coming towards the end of that function, you are supposed to have the right brace. The right brace indicates the end of the function's body. In our case, we are dealing with a function called main. So the pair of braces, the left and the right braces, and the portion of the program between them, that is between the statements, is called a block. The pair of braces and the portion of the program between them, that is the statements, is called a block. This is what we are calling a block, my dear students and the rest of the learners. This section in between, the section in between this left brace and this right brace, this section here is what we are calling the body. It is the body. And you can still, or you can also call it a block. A block. Let's look at statements. Statements are now the set of instructions that we want the compiler to work on. This includes the input instructions that I discussed in our previous presentations in this series. We have the output instructions and processing instructions, or what we call variable declarations. So all that forms statements. Each statement must be terminated with a semicolon. My dear students and the rest of the learners, kindly note that any statement in C must be terminated with a semicolon, indicating the end of that instruction, so that the compiler can then be able to know that is the end and do what is required and then move on to the next statement. So every statement in C is terminated with a semicolon. Then we have the section for declaring variables. We have a section for declaring variables. When we talk about declaring variables means telling the compiler to reserve memory locations in which the values for the data items are to be stored. Is setting memory locations assigned to be used for a certain purpose. So a variable, when we talk about a variable is declared by specifying the item's data type, followed by the name of the variable. And I say that a variable is a memory location that stores content which keep on changing during a certain processing period. So if you have a memory set aside that will be holding values that will be changing as the program runs, like holding one time it is holding a student name, first student, then it holds the next student's name, then it holds the next student name, etc. Because the content is changing, we call that memory location a variable. We call that memory location a variable. So the syntax for declaring data items, the syntax for declaring or setting memory locations assigned to be used for a certain purpose in C are done as follows. One is data type, then space, variable name or variable names, and a semicolon. What does that mean? It means that you tell the compiler what type of value a certain variable will hold or a certain memory location will hold. For example, in this case, I have int age. That means the value to be stored in memory location called the age should be of type integer. And in my previous presentations, I said that integers are whole numbers. Numbers without decimals or fractions. So we have int age, semicolon. If you have several memory locations or variables, if you have several memory locations that will store or hold the same type of data, then you can declare several of them using a cell or a single int statement. For example, int age, comma, score, comma, total. Int age, comma, score, comma, total, then a semicolon. So you can declare several variables or several data types. In other words, you can declare several variables using the same statement. But you remember to separate each of those variables with a comma if they are going to hold data of the same type. For example, whole numbers. Then we have the statement return 0 that you have seen in the structure. Return 0, what does it mean? It indicates that the program execution has terminated successfully, and thus the program control should be taken back to the operating system. The keyword return is one of the several means to exit a function. It indicates that that is the end of the function. What was supposed to be done has been done. Therefore, let the control go back to the operating system to perform or to attend to other duties, or it can be used to return a value, another function of the main function. This line can be completely left out if the return value for main was it. It can also be included without a zero, e.g., return semicolon. I have already explained about return, my dear students, and the rest of the learners. Therefore, the simplest C program structure can be as follows. This is our simplest C structure or C program. Void, main, then we have our parentheses there. We have our left and right brace without anything else. So that's a complete program in C. But what is this program doing? It is doing nothing. What it just contains is the main function. The function is not receiving or returning anything. It is not expected to return anything to any other function, and there is now nothing to be done. But it is a complete program. It has no errors. It has the main function, and the function has the parentheses. Then it has the opening brace, indicating the start of the function. It has the left brace, indicating the starting point of the function. It has the right brace, indicating the end of the function. That's all. So this is called the simplest C program. This can also be written as follows. You can read it as a single statement, as you can see. Void, main, parentheses, left brace, right brace. That's all. There are no statements to be executed here. This function is supposed to do nothing, but it is a valid program, a complete program in C. Let's now look at the structure or format for a Pascal programming language. So Pascal programming language, or in Pascal, this is how we do it, or this is what a program structure is all about. Pascal programming language, number one, is not case sensitive, and therefore the programmer can write the code in either lowercase or uppercase or mix. This is different from C. In C, we have seen that you write all your statements or instructions in lowercase, in small letters. But for Pascal, there is freedom. You can use capitals, you can use small. It all depends with you, but it is good to adopt one which does not sound. Don't make use of too much of capital letters only. You can combine them or you can mix them, but in a systematic manner. However, just as I've said, it is good to use uppercase for the reserved word and lowercase for identifiers and other instructions. Each Pascal program consists of two main parts, which are the program header and the block. So the following is a general format for a Pascal program. Just as you have seen, a format for C. Here we have our comments part. You can see this is the whole structure. So we have the part for comments. This is how we make our comments in Pascal. Look at the difference. In C, these ones were forward slashes. This one was a forward slash. But in Pascal, we have these parentheses and these parentheses. Whatever is in between here is your comment. Then we have the keyword program. Just the same we have seen main in C. For Pascal, every program has to have program followed by the name. This name is the name of your program, and this name should be based on what it is doing. For example, program area. Program area circle, area circle. Then we have these parentheses. So in other words, this is also a function, just as you have seen for C. So every program that you write in Pascal should have this form of syntax. We have program name, we have this bracket parentheses, we have this other one, but later on I will tell you that based on the programming language you are using or the Pascal, this part can be optional. If it is doing nothing, you don't need to have it. So you can have program name terminated with a semicolon. Then we have declarations part. We have keyword begin. Then we have these statements. In C, we have seen that here we had that brace, and here we have this brace. But in Pascal, instead of left brace, we have keyword begin. Instead of right brace, we have end. Let me now move on and explain to you, my dear students, what each of these parts really mean. What each of these parts really mean. Now, after you have your end, there are other ways of labeling this structure of a program in Pascal. This first statement, program name, opening parentheses, input, comma, output, closing parentheses, semicolon, is called program header. It is called program header. So every program written in Pascal has the program header. Then we have this section here. We have this section here. This section where we have declarations, it's called declarations section. Declarations section. And then we have this part here. In between begin and end is a period of itself. We call it a period. This one is called program body. Program body. When you combine the declarations section and the program body, we form what we call a block. My dear students and the rest of the learners, I repeat. Number one, every program in Pascal should adhere to this format. Program, keyword or subword program, name, then optional input, output, part, semicolon. Then you declare your variables. Then you have the begin statements that want to be executed, which can be input statements, output statements, processing statements, etc. And then you have the end with a period, a full stop. That's the general structure. Then this part, which commences with a keyword program, is called program header. Then it is followed by the declarations section. Then in between begin and end, we have what we call the program body, where all the executable statements and the call statements for various functions are indicated. Then the declarations section, together with the statements section, form what we call a block. So that is the general structure of a Pascal program. Let me now move on and explain each of the parts. So this statement is the comments. So whenever you want to add any explanation within your code, you have to enclose it in between the opening parentheses, asterisk. You write your statement there. You close it with an asterisk and the closing brace. Not brace, but closing parentheses. And then the comments can be included anywhere in a Pascal program, either between two braces or between these two symbols. That is between two braces or between a parenthesis. My dear students and the rest of the learners, kindly note that there are two ways of making comments in a Pascal program. We have the first way, you can enclose, you can replace this parenthesis with the left brace, and you can also replace this parenthesis with the right brace. So you can either use the braces, remember in the pairs, or you can use parentheses. You can use braces or you can use parentheses. If you have to use parentheses, you don't, if you have to use parentheses, you must have the asterisk. And then your comment in between here. But if you're using braces, the left brace and the right brace, you don't use asterisk. So you have to adopt one. You either adopt this method of commenting or you adopt this. Whatever you enclose in between those two pairs, between these parentheses and this parenthesis, and between this left brace and this right brace, form a comment. So that's how you add the comments in Pascal. Now, we look at the program header. Let's look at the program header. As you can see, my dear students and rest of the learners, I have already said that program header is composed of the keyword program, followed by the name, then the input-output part, which is optional. This is called program header. It is the part of the program which consists of the reserved word program followed by the program's name, such as name, which reflects what the program is doing. It is also, or it can also have optional file parameters enclosed in the parentheses, such as input, output, then you close that parenthesis. It is optional because it depends with whether that program is receiving any parameters from anywhere, or it is going to send any parameters to anywhere. I will explain more about the same later. But program is a function. So these parameters tell the compiler that the program will get input, such as reading from the keyboard, and produce output, such as writing on the screen, respectively. So if your program is going to receive any entries through the keyboard, then you will have to indicate or to enclose the word input. In other words, this section is going to be included if you are going to make use of keyboard to make entries, or if you are going to display any values to your screen, like using the monitor. So if you are going to make use of a keyboard or any other inputting device, or a monitor, or any other outputting device, then you need to include this part within your program header. But if your program is not going to make use of any input or display anything or give out any output, then you can leave out this section of your program. So those parameters tell the compiler that the program will get input, such as reading from the keyboard, and produce output, such as writing on the screen, respectively. The program header is always terminated with a semicolon, just as you have seen. The block is a section of the Pascal program structure that is composed of the declarations and the executable program statements or program body that are enclosed between the reserved word begin and end with a period. Never forget that whenever you have end indicated at the end of the program, you have to include that period there, which sometimes people call full stop. Then the declarations section. This is the section between the program header and the reserved word begin, in which various data items that are used within the program are defined. All items must be declared in this section before use. So you have to declare all the variables that you're going to use, all the constants that you're going to use, and any other declaration within the declarations section. That is before the word begin. It is the problem that you have that it tells you what to declare. So it is the kind of problem that you want to solve that will tell you what to declare. If, for example, you are going to calculate area of a circle, it means you require radius and you require calculate radius. In other words, you require radius and you require the area. So that will tell you that you need to declare two things. You need to declare or request the compiler to set certain memory locations assigned, one memory location being for the radius, the other one being for the area. But of course, you're also going to require pi. So you also need to declare 3.142 as a constant, just as I explained in part 6 of my series of presentations, or just as I declared in the previous parts in this series. That's why it is important for you, my dear students, and the rest of the learners, to ensure that before you attend to part 7, before you listen to this presentation, kindly go through part 1 to part 6 in this series as posted in EMELISWAP ICT YouTube channel so that you don't lag behind in any information. So the following is the order of declaring items in this section. So this is the order of how you declare the various items that I'm going to be using in a Pascal program. Number 1, you begin with uses. 2, labels. 3, constants. 4, type. 5, variables, abbreviated as VAR in Pascal. 6, procedures. 7, functions. I will explain what all these are in my subsequent presentations in this series. But that is the order. You don't interchange them. Always up there you begin with uses, followed by labels, followed by constants, followed by type, followed by variable, followed by procedures, then functions. In that order. You don't interchange them. You can't begin number 1 being functions and then end uses. That is the specific order of declaring those variables or those items, declaring those items, if you're going to have them in your program. If they're not going to be used in your program, you don't declare them. But if you use them, you declare those that are going to be using. So a data item is declared by specifying number 1, the declaration type. That is data item category. What type of data are you going to have? Then data item, what it will be its name? How will you identify it? And then the data type that is going to be stored. So we have data item category, like variables, identifier, like the name. And then we have the data type. So the syntax for declaring data items is as follows. We have declaration type, identifier or identifiers, colon, data type, semicolon. I repeat, declarations type, identifier, or several of them, identifiers, then colon, then data type, and semicolon to indicate the end of the statement. So what are these things? So an example is variable, var for variable. So the declaration type here is variable. What is the name of that variable? So that memory location, you call it age. What type of data will it hold? Integer or whole number. Let me repeat. Var indicates that this is a variable. This age is a variable. The content of this memory location will keep on changing. It will be changing during program execution. But in as much as it will be changing, it will be holding data of type integer, whole number. So it can have 1, 2, 10, 6, 7. The content will be changing. The memory location, the name of that memory location is 8. So we are telling the compiler, requesting the compiler to do the following, or for us to do the following. Set the memory location aside, called the age, whose content will be changing during program execution. And that content will be a whole number. I repeat, this statement tells the compiler to do the following. 1, set a memory location aside called age that will be holding data which will be changing, and that data will be a whole number. I repeat, you are requesting the compiler to set memory location aside called age, which will be holding content that is a whole number. It will be holding content which is a whole number, but those numbers will be changing during program execution. So var is the declaration type for variable. Identifier is the name of the memory location aside that we'll be using to identify the memory for use during the program execution. Then integer is the data type. And remember, you terminate your statement, declaration statement, with a semicolon. Or if you have several, just as I've said for C, if you have several identifiers, or you want to set aside the several memory locations which are going to hold the same type of data, like whole numbers, then you can declare, and the content will be changing, then you can declare several of them using the same statement. But remember, you separate each with a semicolon, each with a semicolon. Like in this case, this statement is setting memory locations aside of 3 types. Or in other words, this statement is setting 3 memory locations assigned. One called the age, the other called the score, the other one called total, that are going to hold data or content which is a whole number of type integer. And that content will be changing during the period of execution. So age can hold any value at any time, score will hold any value at any time, score total will hold any value at any time, as long as those values are of type integer, they are whole numbers. I'll explain about data types later in my subsequent presentations in this series. The program statements section, what does it entail? The program statement section is composed of the instructions that are executed by the compiler and are separated by semicolons. They are separated by semicolons, and they are usually found in between begin and the end. So begin is a reserved one which indicates the start of the program's body. Then end with a period indicates the end of the program's body. So anything in between begin and end, those are execution, or those are statements that must be worked on by the compiler. As I said in my previous presentations, those statements can include input statements, processing statements, and output statements. So there are 2 types of statements. Generally, there are 2 types of statements. One, we call them simple statements. These are single and conditional instructions that cause the computer to perform a particular action on a single task. They include assignment statements, procedure statements, and go-to statements. Then we have what we call structured statements, regardless whether they are input statements, output statements, or processing statements. And these are a sequence of statements that are executed together as a single statement. I'll demonstrate on the same in my subsequent presentations. They include compound statements, repetitive statements, and the conditional statements. The assignment statement performs a series of arithmetic and logical operations, if any, and assigns the final value of the expression, the variable specified. The procedure statement is used to access a self-contained computational module that we call a procedure, and it is used to invoke a procedure. I'll demonstrate this in my subsequent presentations in computer structured programming series. Go-to statement is used to transfer program control unconditionally from one part of the program to another. Compound statements are made up of a sequence of statements. Repetitive statements comprises of several statements which are executed repeatedly. Conditional statements involves the execution of one or more statements only if a specified condition is satisfied. Compound statements are made up of a sequence of statements. Repetitive statements, I've said, they comprise of several statements which are executed. Conditional statements involves the execution of one or more statements only if a specified condition is satisfied. And with that, my dear students and the rest of the learners, I believe that you now have some basic foundation on what is expected for the general loop of a program in C and Pascal. Continue to section 2 or 5 in this topic on program structure so that you can be able to learn more concerning the format and the structure of programs in C and in Pascal. Congratulations for learning section 1 or 5 of the topic program structure. You can also access section 2 to 5 of this topic. Other topics in the computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit the EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. Subscribe to the channel. Tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in part 8, which will cover section 2 or 5 of the topic program structure. Be blessed.